Well, hey there, everybody. Here are some answers. Hope you're all doing well. Feels like I haven't talked to you for a little while, so here you go. That's I have not talked to you. I don't really get the you've talked to me at all. Thanks, Broden, for those emails. That was good. Glad that you have a job. That's well done, you. So you did before break. I gave you three free response questions to answer. We'll take a look at those. I did screw up a little bit on the third one, um, or maybe the second one. I forget. Anyway, so we'll go over those answers now. Might be kind of long, so feel free to skip forward if you like. I got it. And I'll also make this presentation available too if you want to see my answers to things. So here are those answers. So the first one was from the 2012 exam. This was dealing with a barn that would exist and had a bunch of horses in there. Those are horse objects. Important to note that those are horse objects, not strings. So you would think that a horse would uh, just be its name. But they had a number or something else that was associated with that, so that you had to be a little bit careful on that particular one. So it was a virtual horse barn. Part A was to find a given horse in the barn. That's pretty straightforward. Traverse the loop, traverse the array, and look to see is that name equal to the one that you're looking for. And then part B was to consolidate. That got a little trickier. So that meant that you had a barn, had some empty stalls, and we wanted to shove all the horses next to each other. And then at the end, those would be empty or null, to use the computer science term. So that was the bit there. So how do you find a given horse in a given array of horse objects? You got to go through the entire object. You do need to make sure that you want to store the contents of each cell in an array. But before you do that, actually, you do need to make sure, because we have some cells that are null, if we were to, and we could do that, we could store that in a temp. That's okay, even if it's null, but you do need to make sure that it is a horse object. If you try to get the name from a null object, you get a null pointer exception. And so you do need to make sure that that is the case. You have to extract the name of the horse. There's a getter for that. Then we have to use the dot equals to compare the parameter with the getter of that given horse. Are they the same? That returns true. We return the index of that cell. If we get to the end of our loop and we have not returned anything, it means the horse ain't there. So we'll return a -1. That's the way that's done. So again, it returns an int. Important thing to do. So many times College Board will give you a point, half a point, if you actually do that. So here's my solution to that. There's the method declaration up here. This is a given. Here I'm looping through, starting at the beginning. It's not a sorted loop, so there's no faster way. Can't do a binary search or anything else. That's kind of, I got to start at the beginning and traverse my way all the way through. So pretty straightforward. I do need to do that. All right, so that's a tricky point. And so I am going to say check to see the barn is called spaces. And so if the element at I of spaces, if that is not null, right? So again, remember that exclamation equals does not equals. So if it does not equal null, that means that spaces at I is a horse. So now I can go and I can get the name of that horse and proceed. If I didn't do that and I tried to get the name of the horse, no pointer exception. So here's how I'm going to do it. I can't just compare. The reason I put this in yellow was that it's tempting to say, oh, well, if spaces at I equals name. But remember that these are horse objects. They're not strings. So I've got to call the getter for that horse object, get the name of that. Does that equal the parameter? And if that is true, then I can return it. All right, and that's the end of my method. I'm going to close out. That's the only, so two ifs. If both of these ifs are true, I'm going to return I. That's the index of where that horse is. Otherwise, if I get outside of that loop, hopefully that thing will go away. I'm going to return a -1. All right, so I'm done. The horse is not there. I've gone through my entire list, and then the name of that horse isn't there. So that's how I'm going to do that. This is the College Board's rubric for that. And there's my face covering up their solution. So the first is that you get a point if you just did the for loop. All right. So again, this is really just about trying to acquire as many points as you possibly can for this for this project. So even if I don't know how to do that, hey, that looks like a loop. I'm going to just write some code that is going to loop through. I'm able to access all elements. Guess what? You just got a point. Maybe you return nothing. Maybe you don't find it. Maybe you don't do the -1 thing. Lots of other errors could occur. But if you loop all the way through, you're at least going to get a point. You get a point too if you check and make sure that it's not null. All right, so that if you do that, you're going to get another point. Again, it doesn't say that you do everything else right. So if you do those two things, you've just gotten 2 points out of 4, I think. Yeah, 4. Here I'm going to check to make sure that the name is is the same. Notice that they say that you've got to use the string equality. You can't just use double equals. So you will not get the point if you do that and you use double equals. And then return the correct value or -1. That's the last point. So there's 4 points on that. And there's 5 points for part B, in other words. So this is it's actually 3B. The consolidate algorithm. I'm going to show you 2 different ways. This took a long time to put together. The second way is using kind of a merge sort. This is I don't know, cheap way to do it. And that is, I'm going to make a new array that is the same length as spaces, I think. So it's going to be the same length, and then I'm going to create a temp variable that will keep track of every time that I put a new horse in my new barn. I'm going to increment that. I'm going to go through the array of horses, the old barn, the spaces array, looking to see is it null, and if it is not null, I'll put that in the new one, and then at the end I'm going to assign the horse array to that new object, and I just kind of swap them at the end. I don't know if that made sense, but that's what we're doing. So here's my solution to that. All right, so here I'm going to make a new array. Again, remember that it's void, so do not, if you're writing code for a constructor or you're writing code for that is a void, do not return something or you will be penalized. They'll dock a point for that. So here I'm going to make a new array. I'm going to call it new barn. It's an array of horses, so it's not strings. Make sure that that's true. There's my index for that new barn array that I've made. Now I'm going to traverse the spaces. I'm going to start at the beginning and I'm going to go all the way to the end. Just a nice, easy, simple for loop, the way that we've done. And what am I doing here? I'm checking to see, is it not null? If it is not null, I'm going to put that horse into my new barn. How do I do that? Remember that I've got this new index that's keeping track of where we are in this array up here. And I'm going to put it at I. So I is going to increment all the way along, and new index is only going to increment when there's a horse at a given element. In other words, if there was only one horse in the barn, and so I've got a lot of nulls, I'm not going to be incrementing new index until I get to that one horse. All right. So notice that I start at 0. So that means that the horse is going to be put at 0. Well, then I got to do a couple of things. Or one thing, I'm going to increment space index at that particular point. All right. So space index will increase every time that I make that reassignment. So now at the end of this closed curly down here, I've gone through all of my the array of spaces. All right, so all the horses that are there, all the ones that where there is an object in that slot, that one is going to get reassigned to new barn. So new barn is consolidated, spaces is not. So if I do a reassignment of spaces to new barn, those are just, that's saying I want you to point to this guy now. All right, so that is a legal thing to do. That both arrays of horses were good, and that's it. Don't return it. All right, so that's one way of going about it. I don't know. I'd be curious to hear how that went for you. If that was what you did, if that's totally out in left field. That was my first solution. The other thing is I was doing that and I was going through and we're going to move things back sometimes and we're going to stop, got to make sure we don't go all the way to the end, all that kind of stuff. That sounded an awful lot like merge sort. And this is their solution. I want to point out a couple things on this. So here's my video. Let me see all that. Yeah. Oops. So just the solution, you get a point if you access all entries in spaces. Yep, I do that right there. So I get a point for that. I identify and provides different treatment for null and non-null elements in the array. And here's where that happens. All right, so if it is not null, I'm going to make the assignment. If it is null, I skip it. Assigns an element to the array for the smaller index. Yep, so in new index is not as big as I, theoretically. And on exit, they want to make sure that the integrity, the number, that all of those things are in the right spot, and that all non-null elements are at the beginning, and all null elements are at the end of that array. Couple things so hopefully that's pretty straightforward. Couple things on the penalties though. So again, this is not indicated anywhere in the question. If you return a value, if you return spaces or return new barn, something like that, that's a 1 point deduction. All right, that's pretty severe. But this one I think is incredibly severe. If you consistently use the incorrect name of the array, you don't call it spaces, you call it horses or barn or my R or whatever, any other name, that's a pretty casual error in my opinion, but a very harsh penalty. 2 points off for that, that's a lot in my opinion. So pay attention. They don't make any reference to that at all. But do pay attention to that as you're going through and just make sure that, what is it called? Double check, just make sure, because you could end up losing a couple points that you really shouldn't have. It was just a kind of a careless error. Obviously a compiler would have caught it, and that's where I kind of feel like the College Board is maybe a little stringent on that. Here's my merge sort algorithm solution to it. I'm very excited about this. I feel like a Disney animator here as I walk through this. Although my little picture here is going to be kind of annoying, so I'm going to delete me. All right, so here's the example that they cite. They've got a 7-stall barn, and I've got four horses that are in that barn. Everywhere where there's a null, I'm going to gotta plug in a battery here. Might pause this thing if I can remember how to do that. Come on, where is that thing? Sorry about this. I'll be right back here. Pause. Okay. So let's pick up here. View, present. All right. So when this loads here, again, we have this barn, and what we want to do is we want to shove all the horses next to each other so that we have 3 stalls at the end that are null. All right. So notice that there's an arrow. So here's what I want to do. I'm going to start at 1. Why why start at 1? Why not start at 0? Well, I'm going to start at 0 because if there's a trigger's already there, right? Maybe I don't know that necessarily, but if it's null, I need to put a horse in it. So I'm always going to start at 1 past that. All right. So I'm going to start at 1 and then go forward. All right. And so that one's null. I don't want to do anything with trigger with null. I don't want to switch those guys around. So I have an empty space. So the yellow arrow there, that is the one that is, it's going to move to the right. Okay. So this is going to increment upwards. When I get to these guys, I'm going to create another variable that one's going to go down, just like we did in merge sort. All right. So, okay. So 1 is null. And now what I want to do, maybe, come on, man, is, okay, so I'm going to move over. So I've got a null. I'm going to keep moving over. Now I got a horse, all right? I want to look at the one prior to that. So I'm going to put silver in a temp for the moment. And then I'm going to move him back 1 spot to that null position. And the other thing, now I've got silver in 2 different spots, by the way. Trigger's horse, that was Roy Rogers' horse, silver. For those that don't know, that's the Lone Ranger. So now I've got silver in 2 different stalls. I want to remove him, so I'm going to make him null. And now I'm going to look 1 more spot. Trigger's already there, so I don't repeat that process. All right. And we're done. So now I've got these other nulls in here. So there's nothing to do here. So I'm going to move it up. There's 4. That's also null. Move it up. Okay, now I got patches. So I've got a series of nulls in a row that I want to move patches through. So similar to what we did with silver, I'm going to put patches in a temp for the time being. I'm going to move back 1 and look, is that one null? Yeah, that one's null. Okay, so put patches in the one prior. Now patches is in 2, and then get rid of the one that I was just in. Okay, now keep repeating that process. Notice what happens is that red arrow is going to go back 1. The yellow arrow over here, this is staying fixed. If I move this guy back, I wouldn't know where I was in my list. So I want to keep this one the same, pointing exactly where I was, so that I can go on to Duke, go on to the 6th spot, the 7th stall, when I'm done. So the red arrow is going to move to the left. The yellow arrow is going to move to the right. So I decrease that temp index. That's also looking at a null. Okay, so I'm going to put patches in that one. I'm going to put null in where patches was, and I'm moving patches back. Same situation here. I go back 1 more. There's a null at position 2. I put patches in that. I remove patches from where he was. Now patches is in the right spot. And then I'm going to do 1 more test. I got to look, maybe, I don't know whether or not there's one there. I can see it now, obviously, but the computer doesn't. Oh, there's an object there. That one is not null, so I'm not going to do anything with patches, and I'm done. All right. So the iterator for my for loop, the iterator that's moving through, I dealt with patches. Notice that patches got moved all the way through. Same thing is going to happen with Duke. Put Duke in a temp, look back, there's a null. So Duke is going to go in that, and I can put a null where Duke was. Keep on repeating that process. Isn't that cute? It's a lot of animations for you. And last time, Duke in both of them, then he's going to disappear from 4. And now I am done. All right, it's going to look 1 more time. I don't know if I had that little animation thing. It's going to look at this position here. See, that one is not null, and the inner loop is going to be done. This loop is going to exit because he's at the length of spaces, and we're done. All right. So what is that algorithm? It's a little like merge sort. All right. I'm starting at position 1. I talked a little bit about that. So in merge sort, the first position is already sorted. It could be 1,000,000. It could be negative 1,000,000. It's already sorted. I need 2 to compare. So I'm going to be starting at position 1 for that. I'm going to create that temp iterator. That's the one that's going to get smaller and smaller and smaller and smaller and smaller. All right. there. All right, so the loop through the spaces for number 1 here, that's going to be a typical for loop. That's going to be incrementing. This guy is going to be moving backwards. I'm going to put a temp. That's going to store the horse at that given index. I'm going to have a while loop, and there's 2 different conditions that I need to test for. I got to make sure that the thing about null, that's true, but I got to also make sure that I don't go off the front of the array. In other words, what if position 0 was null? And I keep subtracting, I'll be off the array, and I'll have an out of bounds exception. So I've got to make sure that the temp iterator is greater than 0, and that the previous cell is null, right? And the order does matter. You can't do B before you do A, because if you were at position -1, you're going to get a null pointer. If you check here first and make sure that the iterator, this temp iterator, is greater than -1, not 0, then if that is not true, so let's say, yeah, I keep subtracting, and the first element is a null, so I'm going to look 1 prior to that. If that temp iterator does go negative, that breaks the condition, and I won't have the out of bounds error that I will. So I have to check to make sure that this part is true first. And again, this is not correct, right? It's got to be not greater than 0. It's got to be greater than -1. So I apologize for that. And if that is the case, yep. So there's while loop. Then I want to assign a couple things I need to do. I'm going to assign the previous space to temp, and I got to put the current space to null. And if I do those things, I'm done. All right. So just keep going through I as an iterator. When I finally get to the end, then we're all good. And if spaces add I is a string, but then oh, that's from an old thing. I don't think that's not the case. So through 4s is what we want, right? So so here's my solution using that a different algorithm. So same method, and again, you don't get any bonus points for doing it one way or the other. I just want to show here's a different solution. All right, so here's my way of going about it. I'm going to loop through. I start at 1, go to the spaces.length, incrementing I by 1, and then I'm going to have this index. That's my temp variable. That's going to be I -1, and I know that I'm not off the array because I'm starting at 1, not 0, so I'm okay there. I'm going to store the contents of spaces at I so that's what was there. And there's a couple of situations here, all right? So so here's my index. So this is correct, it was not written correctly on the algorithm, but if the index is greater than -1, that means that it's going to be okay. And if space index if the element at index, all right, that's the one prior, is null, i.e. it's not there, then I'm going to assign spaces at index to my temp. All right, that's this guy here. So this is the iterator that's moving backwards, and so I'm gonna have to, while I'm in this guy, if that's the case, I've got to do. Here's where I'm going to assign that one to null, and I'm going to decrease index. So those are the 3 things that I need to do inside that while loop to move those elements back. I could do one other thing. I could also check to make sure that spaces isn't null too. That would be a good thing to do as well. So that's going to continue on. When I get to this end of the for loop, I'm done with this, and I is going to increment. We'll go on to the next one, and we keep on moving that through. All right, and that should be it. Here's their solution to it. Do I access all of the elements without any? That's just make sure that you don't have any out of bounds errors. So I get a point for that. This is the same exact same issue as before. Um, I've already gone over what that's going to do. So I think that this also is going to get almost full credit. Maybe might have an error in there somewhere. All right, so that was the first question. Again, that was 9 points. The second is dealing with this robot class, and this was a little wonky. You have a robot that's picking up toys. It's an array of ints. It shows how many elements there are, how many toys there are at a given position. A robot can only pick up one toy at a time, and if there is after picking up a toy, that the number there is going to decrease by 1, obviously, and it's going to stay on that cell until there are no more toys at that position. In other words, the integer at that element is 0. And then there are these walls on either end. So it's going to traverse this hallway, I guess. And if it hits a wall either end, the beginning or the end of the array, then it's going to change direction. A couple things so in part A, we're going to write the forward move block, and that returns true if the robot can move forward in whatever direction it's pointed in. It returns if it's blocked. So if is it at the end? Is it at the beginning facing to the left, or is it at the other end at the max value and it's facing to the right? So that's part A. That's pretty straightforward. Part B is to write the move method that picks up one toy at that position, stays at that position until there are no items remaining, and then it's got to do the move. And then the last thing is I forgot the name of that method off the top of my head, but as I flip through the actual question. And not seeing it. Oh, the consolidate. No, that's the horses. Well, one of those guys in there. There it is. The hall is cleared method. I think that is the clear hall method. That does everything. So we've successfully written the move method, and we'll call move multiple times, and that'll pick up all the toys, and then we'll be done. All right, so the first part is the forward move blocked. All right, this is going to return a true or a false. I got to test to see if the robot's facing to the right, if that is the case, and is the position, pause, if that is equal to the length, -1, of hall, then I'm going to return true, false otherwise. All right, so if I'm facing to the right, I'm blocked only if I'm at the very end of that list, the length of the array. If I'm not facing to the right, i.e. I'm facing to the left, then I need to check to see is pause equal to 0. And if it is equal to 0, then it's going to return true, false otherwise. So here's my solution to that. And there's a bug. This isn't going to work. This should be a -1. So I'm going to check, see, am I facing to the right? Yes, I am. All right, then if this is equal to hall.length, well, that's never going to be the case. So the last position is 1 less than that. So that should be hall.length -1. That would do it. If that's the case, then I'm going to return true. Otherwise, I'm going to return false. Notice that I'm returning false here. That's only going to be, I'm only going to get to this statement if I'm facing to the right and I'm not at the end. All right, assuming that I had that one right. Here, at this else, I am facing to the left. All right, I'm facing back towards 0. So now if, and this one is right, if the position is equal to 0, I'm going to return true. Otherwise, I'm going to return false. All right. This was all just 1 point. All right. Admittedly, this is, I think, a pretty old, 2004. So that's a pretty old exam here, 16 years ago. That's a long time. So and I'm not seeing this on recent exams where they really split it up and say, oh, you get a half point if you try it, and get another half point if it's right. They're saying you got to do it right. So this is old. They may, who knows? But that's so anyway. Part A was only 1 point. So I'm only going to get a half a point on mine because it's not correct because of this arrow over here. All right. The move method, this gets a little bit more complicated. All right. So in this case, um, I've got Hall. That's my array of integers, and I want to look to see what's the value at at pause. Is it greater than 0? That means that there's a toy to pick up. So okay, so decrease that what's in that cell by 1. Now I got to test again. Is it equal to 0? If it's not equal to 0, the robot's supposed to stay there. So I have to that's the reason for testing again. So I'm going to pick it up. If I'm going to decrease it by 1, if it's um, equal to 1, and you can't assume, obviously can't assume that there couldn't be multiple toys there. That's one thing. And the other thing is that if it moves one cell, that cell could be 0 too. So you have to do 2 tests. Do a test to see what is it initially, and what is it a second time. At least that was my solution. There may be ways of doing that in one fell swoop, but probably my thinking is no. I think you're going to have to do 2 tests. So if it is equal to 0, that means that the thing can move. If it's not equal to 0, it stays there and we don't have to worry about it. But then I've got to do this. It's got to move. But if I'm at the end of the array in either direction, I've got to flip the facing right parameter, or not parameter, but instance variable. So if I'm at the end, it doesn't move, it just changes direction and stays put. And if its move is not blocked, all right, so in other words, there is a place, I got to increase or decrease pause depending on whether or not I'm facing to the right or to the left. All right, so if I'm facing to the right, I'm going to increase pause so it gets bigger and bigger and bigger and bigger. If it's facing to the left, I'm going to decrease pause so it gets smaller and smaller and smaller. That's it. So how do I do that? Here's the first thing I got to do is I'm going to take a look and see, hey, is there an element at the position that I'm at right now? All right, so Hall at pause, if that is greater than 0, that means that there is a toy there to pick up. Well, if that's the case, then pick up 1 toy. All right, don't pick them all up. Don't assign it to 0. That's, I'm sure, going to be something that the message is going to error with. So I'm just going to decrease it by 1. Now I'm going to do that second test and say, is Hall at pause, is that now equal to 0? All right, so there was 1 there and I picked it up. Great, and now I'm at 0. Now I'm going to move. I'm not going to move if that is not the case. So everything else at this point, if there still is a toy there, that robot stays and will get called a second time when move gets called. So, all right, very fine. Move forward block. If that is true, that means that I don't know if I'm at the left or the right, but I've got to change directions. All right, so I'm at the end of the array, again, either at position 0 or at length -1, one or the other. So this is a way of doing it. You could do a whole nother test to say, hey, is facing to the right, is that true? And if it's true, then set it to false, else set it to true. Or here's a cute little way of going about it. If you set facing right to its opposite, facing right, that's a Boolean. If you put a not in front of it, it switches it. So whatever it is going to be the opposite. If it was true, now it's false, and I set facing right to false. If it was false, then it's true, and I set facing right to true. So this is a way of flipping the sign, as it were, of facing right. Get its current value, do the opposite, set it to that. So if it cannot move forward. I know it's at the end. I don't need to do another test. You could definitely do that. There's no penalty certainly for doing it. Just a little shortcut, if you will. So, and again, notice that it does not move. I don't change pause at that point. All it does is change direction. This else means that it can move forward. So it is not at the end of the array. So I got to increase or decrease pause. To do that, I've got to figure out, are you facing to the right or to the left? So there is another if statement. I don't know another way of solving that problem. So if facing right is true, and again, you don't need this, but it's a little clearer to read and write. So if facing right is true, that means I'm facing to the right. That means pause should be going up. I'm going to increment pause by 1 plus plus. If that's not the case, in all other cases, well, I'm facing to the left then. What's going to pause going to do? Minus minus. And that is it. So that's the close of the method. Notice it's a void. I don't return anything. Don't do that. Here is their solution to it. This was 5 points. If you check for an item on the current tile and move 1. So you get a point if you did this. So that would get me that point. 1.5 if you check the conditions in context of attempting to move or turn. The body of each must, yeah. So refer to pause and or facing right. And so that's what I'm doing here. So I'm doing here's the facing right issue. I think that's what they're getting at there. Change direction, toggle the value. I'm definitely toggling. That's pretty much it. And then the move attempt 2 directions. Oh, if you, not sure why you jump 2, move 1 tile in the proper direction. If and only if the originally is not blocked. I think my code mirrors their solution. I'm not, some of the reading of that is a little hazy in my mind. And so that's the move method. That was also pretty straightforward. And then there's the clear haul method. Well, the clear haul method, there's a couple things going on here. Clear haul is going to call move multiple times. And there's another thing. There's a haul is cleared method. This is a method that is very easy to overlook. First time I read it, I missed it. I was focused on what do I need to write. But then when I got to this part C, I was recognizing, well, wait a second, do I have to like traverse the whole thing, count all the toys and make sure that they're all 0? No. So they've written a haul is cleared method, implement not shown, that we can call. Oh, well, that makes things so much easier. That returns a true or a false. So if it's clear, that means that there's zeros up and down the array, no toys, and it's going to return false otherwise. So that is going to be the one that that's going to do a lot of the heavy lifting. The other thing that they want to know is how many steps does it take? Recognize that the number of steps is not equal to the number of toys. All right, so hey, just be cognizant of that. So I'm going to create a move counter variable, initialize it to 0. I'm going to loop until haul is cleared, comes back, not 0, but comes back true. And inside that loop, I'm going to move, I'm going to increment my counter, and then when I'm done with the loop, I'll return my move counter, and that should be it. So not super complicated. Here's my solution. It takes no parameters, returns an int. There's the temp variable that I make, move counter, set initialize it to 0. And so here is how I'm going to call this. So if haul is clear, if that is false, meaning that their haul is not clear, I got to pick up some stuff. Another way to do that is not haul is clear. So I'm going to move, and I'm going to increment counter. So my move is picking up a toy. It's somewhat of a misnomer, right? Because move sounds like you're moving, you're not picking up, but it definitely is doing that. And I'm going to increment my move counter, and that's going to be the end of my while loop. That eventually is going to keep going, and eventually hull is clear is going to return true, kicking us out of the while loop. So I will return move count, and that method be done. Here's their solution for that I got to declare and initialize that counter. Must have some extra context relevant to counting. Not sure quite what that means, but get a half point for just declaring that. Loop until done. You got to call this. I think that what they would do is initially when I first was thinking about it, I was thinking, oh, well, I'll go through all the elements in that array and count them all up. And so in other words, if I didn't do that, I'd lose a half a point. So you got it to work, but you didn't call that. Anyway, so that's that. That I call move, and that I determine the number of times move is called. So that's I'm incrementing my move counter, and again, half point if it is returned, and if all you did was declare move count equal to 0, return move count, you don't get a point. So that was an error that I noticed in some of them. It sounded like, oh, well, if you return a value, you'll get a point, even if it's not, you don't do anything with it. And no, they don't want you to do that. All right, the last one. This is from a pretty recent test. This was the 2016 exam. Pretty recent, 4 years ago. And in that case, what they're doing is they have this message thing that's going on. So a log message stores a type of machine and a message. Those are both strings. We're going to be writing the constructor for that. And to create one, a single string is passed. It's got one colon in it, has no spaces before or after the colon. That was something that was made. We know that there are getters and setters for those two instance variables. Our job is to write the constructor, and then the contains word. That's pretty similar to the lab, the Magpie lab that we did to say, are you, if you wrote the word smother and tell me more about your family kind of thing. So you got to look to see, it's got to be just that word. If it's disk 3, that's not going to be correct. So it's got to be just that keyword and that keyword alone. So the constructor, how do I do that? I've got a string. I got to identify the colon in the parameter. Machine ID is going to be that message starting at 0 going to the index -1. And then the description is going to start at index +1 and go all the way to the end. So here's my solution. Here's my log message. Again, notice that it does not have a void. It's a constructor, so there's no return type. I'm first identifying where is that colon inside message. And here's the first part. So the machine ID, that is set starting at 0. And then I said, oh, it's got to go to -1. But notice, remember that substring with 2 parameters starts here and ends -1 of that, right? So if I know where the index is, going to this point is going to pick up what it came just before that. So this is going to correctly store what the machine ID is before that colon. The description, that should be lowercase t, by the way, over here. I'm going to start at colon +1. So I do have to add 1 here. Why? Because if I just put colon index, it would start at the colon and go all the way to the end. So substring with 1 parameter starts at a given spot, inclusive, and goes all the way to the end. So if I add 1 to it, I'll be 1 over from that, and it will go all the way to the end. That should be right, and we are done with the constructor. Not very difficult. So pretty straightforward, hopefully. right? And the contains word. This one is a little trickier because you gotta figure out where are you in all of this. So here's my solution to it. I'm going to find the index of the parameter. If it's and by the way, if the word is not, the search word term is not found, it returns a -1. So so I'm going to look for that. If it comes back -1, great, I'm already done. Return -1. If it is out of position, now I gotta if it's either 0 or a positive value, now I've got to look to see what came before that. So I've got to do a front end and a back end check of that word, and I will have out of bounds exceptions if I look before and it's the first word, and I'll have an out of bounds exception if I look after the word and it's the last word. So it's a little tricky to solve that particular issue. So I'm going to check to see, is the index 0 or is the letter before space? If I do it in this order, oh wait, the index is 0. So the word disk is the first word of the description. It will not happen out of bounds because, oh, this part is true. This is the short circuiting concept, right? So it short circuits because index is 0, so it does not look afterwards. If it is not 0, well, then it's going to do this or, and if it found it, then I can look before and it won't be out of bounds. And so if neither of these things are true, well, then the word isn't really it. It said broken disk or something like that, or it was one word, and I'm going to return false at that particular point. I can do the same thing at the end. It gets a little trickier because I've got to add the index, where was the word found, plus the length of that parameter. That's the length of the whole thing. Well, now I know that means that it's the last word of the description. And if that's not the case, then I got to look to see, is that a space? All right. The College Board solution, so that you know, is they did all 4 of those tests. They said, is it is there a space before it? Is the index 0? So they went through it. They had a series of ifs. I'll show you my solution to that here. So I'm going to look to see what is the IND. That's the index for the keyword that I'm looking for. If it's -1, meaning the keyword is not there, I'm already done. Return false. Now I'm going to look to see what is coming before. So if index is equal to 0, what does that mean? It means that keyword is the first word of description. So I can't look before, and there's nothing before it, so that the front end of the word is good. By doing it in this order, this short circuits. All right, so that if this IND -1, if that were 0 and I did that first, then I would have an out of bounds. So I'm going to get a substring IND -1 to IND. That's one single character. It's the character that comes before IND. And if that equals a space, then the front halves of both of these two conditions, either that it's the first word or that the letter prior to IND is a space, the front half is done. All right. So now I'm going to do the back end. The back end is exactly the same, except that it gets a little clunky because I've got the index plus the word dot length plus 1. Plus 1? I think that's right. And you know what? This plus 1 is wrong. Yeah, pretty sure. So the end index is going to be the index plus that length. Yeah, that'd be 1 over. So don't do it that way. I was trying to save space is what I was trying to do on that. So if the index plus the word dot length, if That's not right either. So IND. So that's going to be, oh, no, I'm sorry. There. This part is okay. Sorry. If the index plus the keyword dot length, add those two together. If that equals the whole thing dot length, description dot length, okay, that means it's the last word. We're all good. Or I'm going to find that is the thing that comes after it a space. And I tried to just abbreviate by calling this thing index, but I made an error. All right, so I'm going to start at the last one and then go one other. So this, I'd be looking one letter off. So that'd be problematic. So this is going to make sure this part here is going to short circuit. If it is the last word, so I wouldn't have that, assuming that I didn't have this bug. If that is, both of those conditions are true. Here's my outer if, here's an inner if. If both of those conditions are true, well, guess what? The thing is contained, and I'm going to return true. Otherwise, out of all that, if I get to this last line here, I'm going to return false, and that should do it. There was a part C that I overlooked. And so on the cover sheet, they had you can do this in part A and this in part B. And they didn't tell you about part C. It wasn't a method that was there. And so both of those were only 2 points each, which is, in my opinion, a fair amount of work for only 2 points. And so part C is 5, and I'll share that with you, and you can knock your head against the wall with that. So that's an awful lot. That is the way it goes, and hopefully that makes some sense. That's the solution, and I'll see you on the flip. All right, bye.